Hi everyone, this is the video about the Journal 7 from Group 7, Section 1. These are our group members.
The objective is to analyze copper and cobalt complexes of imine-based ligand L1 using spectral technique. Transition metal complexes are suitable for binding and cleaving nucleic acid, which are significant interest due to the various applications in nucleic acid chemistry. Copper and cobalt are bioessential metals in all living systems, which shows antifungal and antibacterial properties against several pathogenic fungi and bacteria depends on the reaction with the central DNA system. The D block metal complexes activate endonucleotide cleavage reaction in DNA photolytically or with the aid of external agents. Chemically, Lewis acid metal centers are well obtained to influence fundamental cellular process due to their affinity for basic N&O donor ligand. Large aromatic manners capable of interaction with nucleic acid building blocks.
For synthesis of metal complexes C1 and C3, ligand L1 was dissolved in ethanol by heating and intensive stirring. Warm ethanol solution of copper 2 chloride dehydrate or cobalt 2 chloride hexahydrate was added dropwise. The mixture was refluxed over a water bath for 4 hours at 80 degrees Celsius. Then the solvent was evaporated in vacuum. For synthesis of mixed ligand complexes C2 and C4, ethanolic solution of 1,10-phenanthroline was added to hot ethanolic solution of copper 2 chloride dehydrate or cobalt 2 chloride hexahydrate with constant stirring, followed by dropwise addition of ethanolic L1. The mixture was refluxed for 4.5 hours at 60 degrees Celsius. The precipitate obtained was filtered and washed twice with cold ethanol.
This is the general scheme for the synthesis of L1 and its metal complexes. The methods and instruments used in this experiment are shown in the slide. Analytical data of all the complexes C1 to C4 are summarized above. The results obtained are reliable with those calculated for the purpose formulae. The analytical spectroscopy and magnetic data do enable us to predict the possible structure of the synthesis complexes.
Rotational spectroscopy. The free ligand shows a sharp band due to enzymatic group progression. As stated, L1 shows a band for C-double bond anti-alpha ring. Besides, searching vibration OH of hydrated water exhibited a broad band as shown above. Next, the frequency of phenolic OH stretching at 1224 per centimeter because it involved in composition COM. A very broad band at 3500 per centimeter shows the presence of coordinated or lattice headwater, whereas the range band of MO and MN vibration is stated in the slide. Electronic spectra and magnetic moment. Shift base show a strong band at 303 nanometer and 344 nanometer for complexes due to reasons above. The absorption band of phenanthroline at 330 to 350 nanometer due to ligand center touch transfer, while the metal ligand attribute a moderate broadband at 385 to 410 nanometer with maximum absorption as stated in the slide. A distorted octahedral copper 2,4 has a broadband with absorption maximum at 520 nanometer, while octahedral cobalt 3 complexes shows a lower band at maximum absorption 502 to 550 nanometer. The copper 2 complexes exhibited a higher magnetic moment. Number of unpaired electrons differentiate between strong and weak field complexes and shows the oxidation state of metal anion and structure of complexes. The copper 2 ion is supported by the magnetic value, but the cobalt 3 complexes is absent due to reasons above.
That's all from us. Thanks for watching.